Okay, so this is the process of solving a linear programming model using the simplex method, particularly for minimization problem, a standard minimization problem. So this particular problem is a standard minimization problem in that all the constraints are of the greater than equal to sign. We say that a maximization problem is a standard maximization problem if all the constraints are less than or equal to, similar to what we solved earlier. Maximization, tas lahat ng constraints less than. This one is minimization, lahat ng constraints greater than. Well, anyway, the procedure is used even if you have mixed symbols, inequality symbols in the constraints. So given the LP model, the first step would be to convert this LP model into equation. Okay, since the first equation, the first inequality in the constraint is greater than, so as shown in the previous presentation, if it's greater than, you subtract a slack, a surplus, and add an artificial variable. So for x1 plus x2 greater than equal to 8, in converting this to equation, we subtract S1 and add A1 to the left side. And then convert the symbol from greater than equal to into equality. Okay, for the second constraint, it becomes 5x of 1 plus 9x of 2 minus s of 2 plus a of 2 equals 45. Okay, so this surplus variable will have 0 coefficients in the objective function. So we added 0s1 plus 0s2 in the objective. And since we entered artificial variable, we added plus 10a1 plus 10a2. Now, why did we assign 10 as numerical coefficient for a1? Because if we look at all the numerical coefficients of x1, x2, the numerical coefficients are 3, 4, 1, 1, 5, 9, the highest of which is 9. And the lowest power of 10 higher than 9 is 10. Okay, so we assign 10 as the numerical coefficient for both A1 and A2. Okay, so this completes our LP model. So we have already standardized it, converting all the inequality constraints into equation. It's now ready for transfer or setting up the first table, the first simplex table. So we have the S1 and S2, we have A1 and A2. So in addition to the columns for X1, X2, we added S1, S2, A1, and A2. These are the numerical coefficients in the objective function. These are the numerical coefficients in the first constraint. These are the numerical coefficients in the second constraint. Okay, so how did we obtain 530? This is 10 times 8, so that's 80. Plus 10 times 45, that's 450. So 80 plus 450 is 530. Okay. So how did we obtain 60? So that's, okay, so that's 10 times 880. Wait. So let's put an annotation. So after entering all the numerical coefficients and we see that the last row still contains positive entries, the next step would be to choose the entering variable. So it's in preparation for table 2. So the entering variable is x2. It's the variable within the pivot column, which is the column with the highest entry in the last row. So the highest entry here is 96. So this is our pivot column, and x2 is the entering variable. So if there's an entering variable, then we have to identify the leaving variable or the outgoing variable. We do that by performing test ratio. So that's dividing the entry in the quantity column by the entry in the pivot column. So ganun din, 8 divided by 1, 8. 45 divided by 9, 5. So sino yung lower quotient? A2. Okay, so since A2, ngayon yung ating leading variable. Okay, so in table 2, instead of seeing A2 in this row, you will see x of 2. Okay, now what will be the new entries for x of 2? So these are the entries in table 2. So how would our table 2 look like? Okay? So for table 2, itong A2 na to will become X2. Itong 45,590 negative 101 will be replaced by the result when all these entries are divided by 9. So yan, di-divide natin by 9 lahat. Okay? So lahat yan by 9. Okay? So yung 45 over 9 will become 5. So ang bagong entry natin dito is 5. So this will be 5 over 9. Of course, this will be 1. 0 over 9 is 0. Negative 1 over 9 is negative 1 over 9. And 0 over 9 is 0. So ito ngayon yung ating replacing row. Okay, now for A1, it will still be called A1. Okay, the entry in the pivot column is 1. Okay, so what will happen is 1 will be multiplied by the replacing row and the results will be subtracted from the old entries. Since this is 1, so it's like subtracting the replacing row from the old entries. So that's 8 minus 5. The new entry here will be 3. This is 1 minus 5 over 9. So the new entry here will be 4 over 9. So that's 1 minus 1. The entry here will be 0. Negative 1 minus 0 is negative 1 pa rin. So as is negative 1. 0 minus negative 1 over 9 will be positive 1 over 9. 1 minus 0 is 1. And 0 minus 1 over 9 is negative 1 over 9. Okay, so ito na yung bagong entry natin for table 2. The one that you see in red, those are the entries in table 2. Okay, ngayon, since this is already x2, this will no longer be 10. Instead, the numerical coefficient of x2 is 4, so meron na tayong 4 dyan. And also, since A2 becomes a leading variable, we can actually remove the A2 column in table 2. Okay, so that in table 2, this is how it looks. Okay, initially, meron tayong ito lang yung mga naka-red na. But since A sub 2 nga became a leading variable, we can actually delete A sub 2 in table 2. This is our final table 2. Okay, so how do we compute the entries in C sub j? So that's 10 times 3 plus 4 times 5. So 50. 10 times 4 over 9 plus 4 times 5 over 9, 6 and 2/3, and so on. And then Z sub j minus C sub j, so that's 6 and 2/3 minus 3, 3 and 2/3, 4 minus 4, 0, minus 10 minus 0, minus 10, 2/3 minus 0, 2/3, and 10 minus 10, 0. Okay, so is this table optimal? No. Kasi meron pa rin tayong positive entry. So ito na ngayon yung ating entering variable. This is for table 3. Okay, why did we highlight A1? Kasi in the test ratio, when we divided 3 by 4 over 9, we got 27 over 4. And when 5 is divided by 5 over 9, we got 9. So 27 over 4 is less than 5, right? So this is lower than 9. So we highlighted A1. So this is our pivot column. So that means for table 3, so I'm writing in red again the entries that we will have in table 3. So instead of A1, this will be X1. Instead of 10, this will be 3. So itong lahat ng to will be divided by 4 over 9. So it's like multiplying by 9 over 4. So if you multiply 3 by 9 over 4, what you will have is 27 over 4. This will be 1. This will still be 0. This will be negative 9 over 4. Pag tinimes to ng 9 over 4, the 9 will cancel out. This will be 1/4. And this will be 9 over 4. Okay? Tapos, medyo komplikado lang. Yung 5 over 9, we will use it as multiplier of all of this, each of these entries, before subtracting from the old entries in X2. So, kumbaga, what we will have here is 5. So, for this cell, in table 4, we will have 5 minus 5 over 9 times 27/4. That's why, guys, I used Excel. So 9 and 27 will cancel out. So cancel yung 9, this will be 3. So what will happen is we will have 5 minus 15/4. That is if you are doing things manually. But if you are using your calculator, you can just enter it and the calculator will immediately give you the answer. So this is 5 times 420 minus 15. So that's 5/4. Or in Excel, automatic niyang gagawin niyang 1 and 1/4. Okay, so ang entry dito magiging 1 and 1/4. Okay, so ito naman, yung para dito, that's 5/9 minus 5/9 times 1. O di syempre 0 na yan, which is as expected. Di ba sabi ko, yung pivot will become 1 and all the remaining entries will be 0. So para naman dito, so that's going to be 1 minus 0 times kahit na ano naman, 0 pa rin. So 1 pa rin to as is. Diba? 0 times 5/9 to. Which is still 0. Okay. So yun, and so on. And then the results will be in the next table. This is what will happen. And this time, when you do the computation, all the last entries are zeros and negative. So the optimum solution is x1 equals 6 3/4, x2 is 1 and 1/4, and the minimum value of z is 25 and 4. Okay? Question, guys?